Hi, I'm Steve Yee with Xamarin.
And I'm Dan Waters.
And today we're going to be talking about Test Cloud and also UITest. And so Dan, what is UITest and how does it relate to Test Cloud?
Sure, so Xamarin.UITest, it's a NuGet package that we've released. It's more or less a C# front end to our Calabash framework. So Calabash is an open source, very popular testing framework for doing cross-platform mobile tests. We've seen a lot of demand for C#, so this gives you that ability.
Okay, and what makes C# a great choice for creating tests on mobile platforms?
Sure, so first of all, C# is compiled. I think a lot of people are a big fan of that. You know, once a test suite gets really big and complex, a little typo here and there throwing you off is not a pleasant experience, so being able to compile it, first of all, is really great. Second of all, it gives you a lot of great ways to manage complexity in the application. So lots of different tools, ways to separate out classes and files and such. And then lastly, the fact that you've got all these great operators and link and collection operations and such gives you a lot of really powerful tools at your disposal to be able to do things like complex queries and get through it quickly.
Okay, and now as UITest, does it use things like NUnit that a lot of developers are already familiar with?
Exactly, yeah. So UITest is actually based on NUnit, something that most people should be really familiar with. Test fixtures, test methods, setup methods, all of that. So really a UITest project is just an NUnit project with an added NuGet package on top of it.
Okay, fantastic. And this being done in C#, does it limit the types of apps that you can test with Test Cloud?
So actually with Xamarin.UITest and Xamarin Test Cloud, you can test any native application or hybrid application. So whether you use the Xamarin toolset to create that, or you use Xcode, or you use Android Studio, whether your application is comprised of web views, we're able to test all of that.
Okay, great. And so you've created a little demo to actually demonstrate this, right?
Absolutely, yeah.
Okay, let's look at it.
Okay. I'm going to click New Solution here, and I'm going to base my solution, my project, off of an NUnit library project. So the way that Xamarin UITest works is that it's based off of NUnit, so you have all of the sort of usual NUnit conventions for creating tests, meaning test fixtures, tests, test methods, and of course the NUnit runner that's available to you. So I'm just going to call this Xamarin Store Tests. We'll create that project. It will resolve the NUnit dependency. And then I'm going to come over here to the solution view, and I'm going to add another NuGet package. Right-click, Add Packages. We need to bring in Xamarin.UITest from the official NuGet gallery. If you don't see it there, you can just search for it up here. Xamarin.UITest. And there it is. Go ahead and add it. So the first thing we'll go ahead and do is we'll take a look at the code that's been generated for us. We have a test fixture. I'm going to remove these parentheses because they're redundant. We have a test fixture which represents one feature, or sort of like a vertical slice of your application that you want to test, but generally one feature, like login, for example. And then under that you have several test cases or different scenarios. For example, a valid login or a failed login. So I'm going to call this ordering test. And I'm going to call this scenario can C add to basket button. Because basically we're just going to click a couple of things in the application and then verify that some UI is visible on the screen. Next I'm going to create a little private string path variable. And this is going to point to the APK that I want to test. To make this really easy, I'm just going to add files from my desktop, and I'm going to add the APK file directly. I don't have to do anything special, I don't have to re-sign it, and we're going to make sure that we are copying it directly to the directory. Now, ideally, you'd be pointing this to the output directory of wherever your application builds. So it's always going to be using the latest version of the test. But just for the sake of this, for getting started, learning how to automate a little bit, this will be the easiest way to do it. Let's right-click here, go to Quick Properties, and then check Copy to Output Directory. What that's going to do is every time we build the tests, the APK file will always be in the bin directory, which is the same place that the tests are executing from, which means that as far as the path goes, we can just type in the name of the APK, com.xamarin.xamstore.apk. Great. Now the next thing that we need is we need our interface to the application. So the way that Calabash works, it builds in a little test server to the application, and then it uses JSON over HTTP to send commands to the application, which then responds to those commands. So we need to use that sort of bridge. So we're going to use Xamarin.UITest, which gives us access to the C# framework, and we're also going to use Xamarin.UITest.Android to give us access to the Android stuff. And lastly, we're going to use Xamarin.UITest.Queries because this is going to enable us to reuse different queries. You'll see what that means in just a second. I'm going to create a local field here, a private Android app. And we're just going to call that app for now. Next thing I'm going to do is create a public void setup method. This is going to run at the beginning of the test fixture, and we mark it with a setup attribute. What we're going to do here is set the app equal to configure app. This comes from Xamarin.UITest. Configure app.android.apk file, pass in the path that we just set, .start app. And this Fluent API enables us to configure the testing environment with the app that we want to test. Now, when this gets to Test Cloud, when you issue the upload command, it's going to pair the app with the tests, and then this path won't be relevant anymore. So this is just for local testing. Now, I'm going to go down into our test method, and I'm going to call app.REPL. So a REPL is a read, evaluate, print loop. And it's just like a terminal. You type a command into it, the terminal evaluates that command, does some processing, and then prints out the results, and then continues to do that over and over. So the REPL for UITest enables us to go into the application and then reflect on sort of the structure of the application and all the different UI elements, and then give us a lot of information about it, which is going to enable us to actually perform the automation. So I can build this, and you'll see here that this is a really small little unit test. It's only 27 lines of code, and it is in fact a UI test. So I'll click Run All, and then I'll pull up my Nexus 4 emulator here. And you'll see that the application launches, and we get a little pop-up window that is the Xamarin.UITest REPL. So you see here it says the app has been initialized to the app variable. You'll also notice that this is the unactivated mode of Xamarin.UITest. We didn't provide an API key, but in the next video we'll definitely make sure that we show you how to do that. The first thing that I can do that's really easy to understand what's on this screen is just to type tree. And then you get a nice printout of all of the UI controls that are currently visible on the screen. You can also do interesting things to verify that certain things on the screen are what you think they are and have the ID that you think they have. So for example, this button up here, I think that this is probably cart menu item. So I'll copy that, and this is a nice trick to use. I can call app.flash, and I'm going to flash the ID that has the cart menu item as the ID. And you'll notice that it flashed up there in the top right corner of the application and then dumped a bunch of JSON data about that particular screen element. So if you look up here again, and then I execute that command again, you can see that it's flashing, which is great. Now the next thing that I want to do is I want to interact with this button in my script, but I don't want to interact with it based on that text, because what if that text changes, or what if it's dynamically generated and I don't have a predictable label for that button? So in that case, what I want to do is use app.query to find out more information about it. If I just do app.query with no arguments, I get JSON data for the entire screen, for every single screen element. But that's a little bit much to sift through. That's why tree is nice. But then I can also filter my query results by typing app.query, and then I can give it a lambda expression again. I'm going to look for the element that has the text, men, C# t-shirt. And there we go. It has an ID of product title. Now I can interact with that by typing app.tap, e.id is product title. And there we go. Now we're on a new screen. I can type tree again and get more information about what's on this new screen. And you can see that immediately there's a button on the screen that has the ID of add to basket and the text add to basket. So then I can do app.query again based on ID, always best to do it on ID, and I verify that it's there. So that's the extent of this particular test, just to keep it short and simple. I click on the men's C# t-shirt button and then verify that I see the add to basket button. So I can copy this. That'll copy everything that I did and allow me to paste it as general, like perfectly valid C# code into my test. So you can see that I did all these things. I know what all the IDs are that I used. It becomes very, very handy. Now when I type app.query, you'll notice that it takes an argument of func app_query. So this is how you sort of save a query to be used multiple times. So there are two UI elements that I'm working with in this test. The first is the men's C# t-shirt button, and the second is the add to basket button. So I'm going to create a func app_query, and I'm going to call this variable product button query, and I'm going to just type that same Lambda expression right here. E goes to e.id product title, like that. And then I can do this again, func app_query, and the next button that I wanted to look for was the add to basket button query, and then we'll do the same thing. Lambda expression, E goes to ID, add to basket. Cool, so we have our two queries. I'm going to go ahead and remove this. The next thing that we'll do is wait. So generally, as a good practice, you want to wait for a UI element to show up on the screen before you try to interact with it, because that's what a user would do. But it's also really important because if you try to interact with a button that doesn't show on the screen, the test will fail, right? And it will time out looking for that element. So we always want to make sure that we're waiting and giving the test and the application enough time, especially when you run it in Test Cloud and you might have slower devices or different network responses. So it's always best to do some waiting beforehand to ensure a stable test. It's this easy. You just do app.wait for element, and then you give it the query that you want to wait for. And then you can also give it an error message. For example, timed out waiting for for the product for the men's C# t-shirt button. And that information will be surfaced in Xamarin Test Cloud, which means that you have total control over what you see as far as error results go. So now that we've waited for it, we can tap it, and we just use the same query. Very easy. And then now we're on the next screen. So what I can do is I can look for that button that shows up, the add to basket button. But first, I'm also going to wait for that. So app.wait for element, because we are in a screen transition, so things may be loading again. So we'll just wait for it. So what I'm going to do next, now that I know that that button is going to be on the screen, is I'm going to try and catch a reference to it. I'm going to do it in this way. I'll do var button equals app.query, the add to basket button. And what this is going to give me is a list of app results. So I need to get the first one. We're only expecting to see one. I'm going to go ahead and use system.link to enable me to use some nice collection methods. This is expecting that there will be exactly one of these buttons on screen, or it will return null. So if there's nothing on the screen, it will return null, and if there's more than this, it'll return null. So it's always good to fail fast. And this should return me a single app result. So now I can turn this into an assertion. Assert.isNotNull button. So what we've just done here is a great example of AAA testing. Up here we've done arranging, and then down here we are acting, and then down here we are asserting. So this is a AAA test. I'm going to go ahead and run it again in the emulator. And again, this is the Xamarin Android player that we're looking at right here. And it's already actually finished the test, and you can see that the tests have passed. So we can run this one again, and you'll notice that it's going to relaunch the application. It'll tap the men's C# t-shirt button and then verify that the add to basket button is there. And over here you can see that the test results are green. So then we'd feel safe about pushing this into Xamarin Test Cloud. And hopefully you get to see what it looks like across many devices. So that's what we're going to do in the next video. I hope you enjoyed this and learned how to create your very first test.